Hello, and thank you for joining us today. My name is Michaela McShane, and it is my privilege to welcome you to the NASA T2U Innovation Series. This webinar series features firsthand experiences and best practices from distinguished instructors at colleges and universities around the country. These instructors have valuable perspectives about the educational benefits of working with NASA-developed technology and an understanding of the entrepreneurial value of leveraging NASA IP resources to start tech-based companies. Before we get started, I'd like to point out that your microphones will be muted throughout this presentation. So if you have any questions, please type them in the chat box and we will answer them during the Q&A session at the end. Today we will hear from Dr. Lin Jiang, an assistant professor of entrepreneurship at the Muma College of Business at the University of South Florida. But first, a little background on the technology transfer and T2U programs. NASA's Technology Transfer Program ensures that innovations developed for exploration and discovery are broadly available to the public, and our Tech Transfer Expansion Program augments that mission to include a focus on entrepreneurial innovation and strategic partners to help accelerate commercialization. That's where T2U comes in. The Technology Transfer University Program brings NASA-developed technologies directly to entrepreneurially minded students and helps NASA build relationships with innovative colleges and universities around the country. We invite you to visit NASA's T2U website for more information about the program, and thank you for joining us today. Our speaker, Dr. Lin Jiang, has taught courses in strategic management, creative and innovation entrepreneurship, and strategic marketing assessment for new technologies at both the graduate and undergraduate levels. Dr. Jiang received her PhD in management from the Scheller College of Business, Georgia Institute of Technology. She holds an MBA and a Master's of Science in Information Technology Management from the College of Business Administration at Creighton University. She also holds a bachelor's degree in information science and economics from Peking University in China. And with that, I will hand it over to Dr. Jiang to tell you about her T2U program.
Thank you. Thank you, Michaela, for your introduction. And I appreciate everyone coming on to this webinar today, or everyone who is currently watching this video afterwards. I think you are here mostly because you might be interested in NASA's T2U program and how it can help you or the students in your classroom. So during the next 20 minutes or so, I hope to share with you my experience and talk about how I integrate T2U into my course. I will first talk about the resources available from T2U for my course and not actually for any courses as well. And then some background information about the course so that you know the context. And then I'll talk about how I integrate the T2U resources into that course. So hopefully this webinar can give you some ideas on how you can use T2U for your classroom. So I started working with T2U in spring 2021 and have done that ever since for 4 semesters. So this spring will be the 5th semester for me. And over the years, I have had lots of fun and of course some struggles as well, guiding my students working on different technologies from NASA. And the slide here shows you some examples of the technologies that I picked for my classroom. And these are just a snapshot of a large number of patents available from NASA for T2U program. So as you can tell, I know this is very small for you in the screen, but NASA doesn't just have aerospace patents, right? They also have patents in many other categories that might interest your students. So this kind of leads to, whoopsie, I don't know why that happens. This kind of leads to my first topic that you probably saw the slide already. What resources are available? So T2U resources. And first of all, the patent portfolio. There are about 15 categories of patents from NASA through T2U. Of course, not all of them, not all NASA patents are there, but for those that are listed on the T2U program, T2U made a very good job, like easy to understand top sheet for each IP. So here is an example of a top sheet for technology that I use for my classroom. By the way, I never meant to have you read through all the text on the slide, but I show this to you to just illustrate that T2U do not just throw out a patent number to us. Instead, they use these easy to read flyer, kind of as an entry-level document for people like you and me and our students to get to know about technology so that we can decide whether this is something that interests us or not. Later, if you want, you can read a patent, of course, to drill down into the details. So other than patent portfolio, T2U provides licenses, and they pretty much streamline the licensing process. They have 1 year free exploratory license for educational purpose. But if you want to pursue the license to use the technology as a startup company, then you might want to get a startup license, but there is a discount fee for discounted licensing fee for that. Other resources available from T2U that I have experience with, these are the personnel visits from T2U. They provide virtual visits to the classroom, and students are often thrilled to be visited by NASA folks. Portals. So if your students need to find out information about a NASA patent that is not on the top sheet or in the patent or Google, right? Maybe some know-how from the inventors, they could reach out to the T2U personnel to get help because they can connect the students to the inventors or as a bridge. So I use all the resources for my courses. So how could you use those resources for your courses? As I mentioned, I will use my course as an example. So to do that, I will need to give you some background information about my course so that you can see the integration in the context. I'm sorry, I don't know why the slide just keep jumping. The course that I use to integrate with T2U, which is circled right here on the slide, Strategic Market Assessment, is one of the required courses in our master program here at USF. It happens to be a graduate level course since I teach graduate level students mostly recently. But I've seen other faculty members in other institutions integrating T2U into undergrad level courses and work very well too. So for my class, and this is in the master program here, that is actually a program that includes an element of technology entrepreneurship, which is about commercializing new technology for market opportunities. So the course that I teach, the Strategic Market Assessment course, is about analyzing and evaluating the market potential of a new technology. And the technology can be one from a university, from a company, or from an organization like NASA. So my goal is to teach students how to evaluate a new technology so that it will help them decide whether they want to go forward with it and commercialize the technology, and if so, in which market segment. So I guess you can see my course focus a lot on evaluation and assessment, but I can see the T2U program can integrate and work with many other courses as well, like new product development, intellectual property, social entrepreneurship, new venture formation, any courses that you have and that involve using a new technology for real world application. I believe that this T2U program will potentially be a great fit to integrate. So, so for my course, the goal is to teach students that once given a new technology to evaluate, maybe from their boss or from their client, they should know how to do it and feel comfortable with doing it. So in the past, we have asked students to evaluate university patents because just like NASA, universities like USF are sitting on a pile of IP that may never get a chance to be commercialized. So there is a big opportunity for students or others to evaluate those patents and get them into the market. And later, I adapted the course so that the students can use what I teach in the classroom for evaluating NASA patents. So during the course, I teach students a roadmap that students can use to learn how to evaluate a new technology. I believe the details may not be relevant to you today, so I will save time for others. But the evaluation task is very time consuming, which I want to point out, since evaluating any new technology can be very challenging, right? So I have students to work on this as a semester-long project. And to avoid procrastination, of course, I have had to have them report milestones 3 times during the semester before the final project due, so that you don't wait until the last minute to work on the project. So that's kind of like the basic context with my course. So how to integrate the T2U resources into a course like that? Let me walk through it so that you may see the possibility for your course. So first of all, students choose NASA IPs from either the entire pool that's available from T2U portal or from a selected set of patterns that I selected for them. I know that some other faculty members integrated this T2U program into their course by having the students to choose the technology from the entire pool. So they basically have students to search a pattern using or technology or IP using the keyword and find the one that interests them and to work on that. I personally like that approach a lot, and I believe it should work the best if the purpose of the course is to have the students find the technology, find a solution, and start maybe a company of their own and exploit the technology. But the purpose of my course is different. It's mainly to be able to assess any new technology that's given to them. So I choose to handpick a couple of new technology from NASA and give that list to students so that they can choose one of them from the list, and which actually turned out to work very well. Because first of all, the course is about evaluating technology that might be given to them. And second, it works well because students do get chance to have to be able to choose a technology, even though from a limited set. But because they choose the technology themselves from the set, they have the curiosity and motivation to work on it for the whole semester. Third, I pick patterns that involve knowledge domains that my student population are comfortable with. So these are mostly, my students are mostly business students, and some of them may be STEM students from engineering or life science, but mostly business students, right? So I avoided those very technical IPs and instead focus on those IPs that the students are more likely to be familiar with, like consumer technology, farming, certain biomedical technology. They are easy for them to understand. And then from that list, I have the students choose which technology interests them the most, so that the students, who choose the same technology would have the common interest and would form a team. In my experience in the past, none of the students that I had complained about these technologies. Okay, so that worked out very well. And another resource that I use, virtual visits from T2U personnel. And Delvin and Trent, they have been tremendously helpful during the past few semesters. And also students are often thrilled to meet with them as well. So that's an incredible resource I have from T2U. And because this is a semester-long project for me, right? So there are 3 milestones for the students. And so I kind of arranged their visits in 3 times. So the first visit is usually in the first class, around 20 minutes or so. So Trent or Delvin would come to my class virtually to introduce the T2U program and sometimes the technologies to the students. So just by seeing the real person from NASA, students actually can easily get interested and motivated to work on the technology. So that was a strong motivator to start with. And second visit I usually have is in the middle of the semester when students have lots of questions. So I have them come visit for a Q&A. It can last anywhere from 30 minutes to 2 hours, depending on the students who have the questions, and also depending on their T2U's availability. So by that time, students usually have had some understanding of the technology and of course also a lot of questions. And so Trent and Delvin have been very helpful in answering questions of my students during the middle of semester. And they can also help providing feedback to the students about their progress. The final virtual visit from T2U is at the end of the semester. So folks from T2U and sometimes some inventors also came to listen to the report. And you know, this is a real motivation for my students because there's a real audience out there. It's not just their classmates, right? So they work really hard for that. So now I want to quickly share with you a sample project, come back, from my class. So you can probably get a closer look of the integration. So in this sample project, students picked the nanosensor technology that I showed you earlier. And again, I know it's very small, so you don't have to read. I don't mean to let you read the text here. Basically, it's a low-powered, compact nanosensor chip that you can use for medical diagnosis purpose. So students, once they get to know about the technology, they start doing research on about the IP, also the IP landscape, and to kind of understand the IP competition for this patent in order to figure out the technical potential. During that process, they came up with an idea of using the nanosensor not for medical device, but for food testing. And so I think based on their research on the technology and their Q&A with T2U, they believe that this was a viable solution. You can imagine that for food testing, you don't have to go through the FDA approval process like what you would have done with a technology for a medical device, right? So they choose this direction and they went ahead and did market analysis for food testing. And they did competitive analysis for the industry to find out competitors. And so the competitive advantage and disadvantage. And finally, they did, that was the slide that just flashed by. They figure out how to go about commercializing the technology for the food testing market. So that's a very quick go through, I know, but I hope this example kind of helps you see the students' output. So the outcomes from the integration with my course. So during the past 4 semesters, there's been 1 semester with a evaluation license initiated by one of the students. Again, my course is about assessment, right? So students may assess the technology and decided that it's not the right one for them. So they may just give up commercializing the technology. But if it's a course with the purpose of starting a new business plan, where students are allowed to pick a technology for their own purpose, I believe that they're more likely to go ahead and do the licensing down the road. And there have been like more than 10 virtual visits from T2U. There has been a very strong appreciation from my students for the opportunity just to work with the NASA folks and to work on the NASA technologies. And at the end of the semester, students receive certificate from NASA, which could probably help them with their career down the road. So lessons learned. I think during the course, their personal interest in the technology is very key. So having them be able to choose a technology, either from a set of the patents or from the bigger pool is very important because that motivate them to work hard on the technology because it's hard to understand a lot of the technical aspects. And with that, I think the second lesson related to that is do not just leave the students with their selected technology and let them figure out on their own. I think it's very challenging. So so students from actually both the STEM side, engineering side, and business side appreciate a very programmatic guidance. So you need to give them the guidance on not just on what technology is, but also how to read the patents, how to do patent research, and Also, the virtual visits from NASA are very helpful as well. And lastly, interdisciplinary teams work the best. If you have students all from the business side as a team, they usually would have a hard time grabbing the technical aspect of the technologies. And so they may be constrained from seeing the potential and the weakness of the technology. But if you have students all from the STEM side, they will have a hard time connecting the technology to the market, like figuring out who could be the buyer, like just the simple thinking process of who would be willing to pay for the technology is something that they struggle with. So you need a team from both sides to kind of complement each other. And I think this the slide that concludes my talk. So I hope these help. And if you have any questions about content in this webinar, please reach out to me through this email.
All right, thank you so much. That was an excellent presentation. We have received several questions about your talk. Thank you to everyone who submitted, and please feel free to continue submitting your questions in the chat box in the right hand of your screen, and I'll go ahead and get to the questions that we have so far.
Good.
So first and foremost, how did you get involved with the NASA T2U program?
Oh, that was interesting. I initially wanted to talk about that, but I thought it was irrelevant to the audience, so I dropped that slide page. It's word of mouth. So So I think it was in December, end of December of 2020. My center director told me that one of the alumni from our program, who was actually at the Florida Polytech at the time, worked with T2U. So, and they had a good experience with T2U. And so that put me, that interested me, caught my attention, because I was about to start teaching this course. That was actually the second semester, so I wanted to do some changes as well. And so then we got connected with Delvin afterwards, and quickly we just got started from there. So word of mouth, yeah.
Awesome. Can you speak a little bit more about how students typically engage with NASA scientists, engineers, and technology personnel for this educational experience?
I would say mostly through the virtual visits. And like I said, 3 virtual visits that allow the students to interact directly with Tran and Delvin during the class. And that was very engaging for the students. And they also had a chance to email them directly for questions. And I usually, that's chance request as well, like having the students compile the questions into one email, and they will find the answers. If it's the technology not for the Kennedy Space Center patents, they will go look for the answers from other centers as well, and then come back to the students with answers. So, so emails and virtual visits. Yeah.
And just a quick note on inventor support for T2U programs. The NASA patent portfolio contains over 1,000 patents at different stages of technology readiness and current inventor support. Right. So whether or not there is someone around to answer those questions just depends on the technology. So we definitely do our best from the Technology Transfer Office to answer as many student questions as possible, but it isn't always possible to do that to the extent we'd like.
Yeah,
just a quick
sometimes
note.
I had inventors join the classroom because they are available, they're interested, they're still working on the technology. Most likely that was because they are still working on it. Most of the times, a lot of inventors move on to other projects, so they are unable, they are not supposed to, they work for NASA, right?
Yeah.
So they are full-time employees working for NASA, yeah.
Yeah, but there is, we have heard a lot of positive feedback on T2U from our inventors and technology transfer personnel, that the students give them good ideas as to alternative marketing ideas that they hadn't considered for the technologies in the past. So there is benefit back to the agency as well in that respect. So someone asks, is the presentation going to be available to view another time? Yes, this webinar is being recorded and will be available on our YouTube page probably by the end of the day tomorrow, but it will be recorded and available. All right, let's see what we have next. Can you share an example of a student technical application that has come out of your class?
The technical application that came out of my class. As I mentioned, the purpose of the class is not to come up with the application and starting a new business on the technology. They basically evaluate the technology and find out what's the way, what's the best market for this technology and how would they go about commercializing it. So they usually stop there. I only have
Mhm.
one student in the past that actually wanted to take it further, and so he got the evaluation license. During that time period, he decided it was probably not a fit for his career, so he stopped there. But I think, yeah, so it's if your course is about like commercializing the technology as a startup company, and students go ahead and look for a pattern that can solve their problems. So if the process is like that, then I think the students are more likely to go further steps into the marketplace using the technology. Yeah.
Mhm. Thank you. Um, Besides choosing technologies that you feel your students would connect to and be comfortable with, do you take any other factors or information into consideration when approaching the course?
Can you repeat that question again? I kind of got.
Yes. Besides choosing technologies that you feel students would be comfortable working with, did you take any other factors or information provided by NASA into consideration for the course?
Oh, other information from NASA, I think in the beginning of semester, yeah, I choose the technologies, and also I got some input from Delvin about whether the technologies have already had licensing agreement contract out there,
Mm-hmm.
and so that we know maybe there's potential competition out there. Um, there's also a question about whether the inventors will be able to provide support. So I got some information at the beginning, and during the semester then, the interaction is more about like asking questions, right? So maybe students may ask Delvin like, can we get information about the inventor, about what the inventor is working on right now? What's the current project? Or what's specific about this technology that may help to solve the problem? So some of the questions may come up during the process and might get answered through T2U. And then at the end was the presentation giving us, so T2U folks give us the feedback. So I think that these are the mostly the interaction points where we get information from T2U. Yeah.
Mm-hmm.
And a lot of others, like how to do research, how to research about the technology, this is outside NASA. So as instructors, I provide those resources to my students.
Mm-hmm. Thank you. This next question asks, do you teach this course in person or virtually? And if you teach it in person, do you think the course could be taught virtually?
That's a great question. I actually started by teaching it virtually. That was during the pandemic. And then in the past 2 semesters, I started to do that in person. So based on my experiences, you can do it both ways, but I do feel for my course, particularly, the in-person works better than
Mm-hmm.
the virtual, because it's not about instruction, but more for students meeting, because for semester-long projects, students meet a lot, and virtual meeting are always much, much more challenging for students
Mm-hmm.
to get like the bonding, the trust among them to work on a very hard project. And there can be pivoting during the process. They might choose to do one application and then choose another, and then they have to go back and redo the research. So that back and forth, that kind of challenge is easier to deal with if they are meeting in person. So from the team perspective, I think the in-person works better, but otherwise, it should work both virtually and in person. And the visit from NASA is virtual visit anyway. So yeah, so I think it
Thank
works both way. Yeah.
Yeah, and to speak to our other programs, we have. I know that there are many T2U programs that are run fully virtually, so it is definitely possible to do that. Okay, I think we have time for one more question. And let's go with, what advice would you have for a new professor who wants to start this program at their university in the coming semesters?
Oh, I think my advice would be think about whether your course has anything to do with using a new technology for a real world application, either is for solving the problem or starting a new business, or maybe just as a case example, something like that. And if that's the case, then this might work for you. And I would suggest looking into the T2U introduction and also the patent portfolio and see what are the patents out there that you might be able to use for your class. And then definitely reach out to the T2U personnel in your, I think NASA has several centers around the country, right? So maybe if you're in the West Coast, that would be a different set of people to reach out rather than for me, it's Delvin and Trent because I'm in Florida. So yeah, reach out to them and schedule a meeting with them and see whether there's a fit out there. And mostly from the perspective of students, right? So what could they benefit from working on technology from NASA versus from another place? So yeah, these are the things I would consider if I start, you know.
Thank you. And yes, to that point, T2U is administered regionally for the most part, although it is virtual. If on our website, there's an email that you can send your inquiry or request to start a program to, and we will match you with the center that is closest and most able to take on the new project. So that would be a good way to get started. And that is all the time we have for questions today. If we didn't get to your question during the Q&A session, we will follow up with you by email within the next week. We appreciate everyone taking the time to be with us today, and we hope you have a wonderful rest of your day. Thank you all so much.
Thank you, everyone.